In this last video, we're going to just take more examples and walk through all of these steps and a little more practice with each of the strategies for assigning RNS. So here's a kind of a summary slide of the steps for assigning and the strategies if you need to pause here and take notes on that. But let's get into the first example. So here's our first example, and there are our three strategies that we've talked about listed over here on the side. I'm not going to show you strategy 1, building and using a model. If you would like to pause the video and build this molecule and then try and assign RNS using your model, that's great, and I encourage you to do that. It's just hard to show it for me to model that here. What instead I'm going to do is I'm going to do strategies 2 and 3, both with this molecule. We're going to get the same answer. If this molecule is R, both strategies should give me R. If this molecule is S, both strategies should give me S. And then what you could do is build the model and prove to yourself that it is R or S. Like you can do that first strategy, building and using a model on your own. I'm going to do strategies 2 and 3 here, okay? And I should get the same answer. So let's do strategy 2 first. I'm going to draw a line, use half the screen for the first strategy, then half the screen for the other one. So, okay, the second strategy is to redraw and rotate your dash wedge representation. So I need to think about, well, it'd be really convenient if this hydrogen that's currently on the line was back here on my dash. So I'm going to rotate my molecule. I'm going to rotate around this single bond right here, and I'm going to draw the framework of my molecule, okay? I'm going to draw the framework for the dash, the wedge, and the line. So I'm going to leave this part the same. This CH2, CH3, the backbone, I'm going to leave that the same. And I'm going to rotate. Basically what I'm doing is I'm rotating around that blue bond, and so when I do that, I'm thinking about rotating this bond. It would be really nice if the hydrogen was back here. So that's what I'm going to do. Hydrogen is going to be on the dash going away. The thing that was on the dash is the OH. I'm going to move that up to the wedge. The thing that was on the wedge is going to move up to the line, CH3, okay? Well, now we're perfectly set up because our lowest priority group is going away. So we can assign priority and do RNS from here. OH, this is my second priority group. This is my third priority group. We're going from 1 to 2, 2 to 3. Look at my cursor, 1 to 2 to 3. I am moving my cursor in a counterclockwise direction. You see that? We're going counterclockwise. So this configuration is S, okay? Now, I'm going to use the other strategy now to try and do this. The answer I get out at the end of the day better be S. So in the next strategy, let's do this strategy over here. I'm going to swap two groups, and then at the end I need to swap my RNS assignment. So let's look at our molecule, and like I said, it'd be really great if the hydrogen was on the dash. So I'm actually going to swatch those two groups around. So here's my backbone. I'm not swapping the CH2, the CH2CH3 or the CH3 part. I am going to just physically swap the hydrogen. And when you do that, maybe make a big deal out of the fact that where those are. Underline them. Make a big deal out of the fact that they are swapped. You pop them off and change them. You've fundamentally changed the molecule by doing this, which is why we have to swap the RNS at the end, because we physically have swapped two groups. This is different than rotating around the single bond. In the first strategy, we moved all three groups. All three groups rotated in the same way. Here we have popped off two groups. That's different. So just make sure you know what strategy you're doing and what needs to happen with that strategy. But anyway, moral of the story here is now we can assign configuration because our molecule is in the orientation with the lowest priority group going back. So 1 to 2 to 3, 1 to 2 to 3. My cursor is moving in a clockwise fashion, 1 to 2 to 3. Clockwise is R, okay? But we swapped two groups, and so we need to swap our configuration. We found it to be R when we swapped them, so we need to swap it back over to S. So see that the real configuration of this molecule is S. Both strategies confirm that. Let's do another example. So here's another example, and this one's really tricky because look where our hydrogen is. Our hydrogen is on the part of the molecule that we usually are maybe holding on to when we do the rotation, right? We haven't seen the hydrogen going that way yet. And so this is an example where I'm not really sure what to do. I think the best option is always to build and use a model. So I would encourage you to do that. I would find that the way that this is presented, it would be really hard to redraw the dash wedge representation because I want to rotate this bond, but that wouldn't put the hydrogen, that wouldn't change the hydrogen, right? Rotating this bond right here, I would be holding on to this hydrogen, and so it would be all these groups that are moving around and rotating, but that doesn't really help me. I need to get the hydrogen going away from my eye. So I think that you should probably build this and double check yourself that way. But we can show how we can swap two groups to make that hydrogen go away from us if you don't want to build it or you want to use two methods to double check your answer. So I'm going to show you how strategy 3 works here, and then, like I said, build it and check that that is in fact the answer. So let's swap two groups. I'm going to draw my structure. The backbone of my structure, sorry. Here we go. Okay. And then I'm going to leave the nitrogen alone and I'm going to leave the CH3 alone. It'd be really great if the hydrogen was on the dash going back. So I'm going to swap that with the sulfur. And then I'm going to take a different color and I'm going to highlight those two groups to remind myself that I did a swap of two groups. So at the end, whatever configuration I get, I need to swap it back from R to S or S to R, depending on what I'm doing. So now let's assign configuration. So this is a really good problem because sulfur, nitrogen, we need to look up the atomic numbers for those. Sulfur has a higher atomic number, so has an atomic number of 16. Nitrogen has an atomic number of 7, okay? So sulfur has the highest atomic number, so that's going to be our highest priority group, so that's going to be 1. Nitrogen will be second, and I know that carbon is an atomic number of 6, so that is an atomic number of 3, and my lowest priority group is hydrogen, and that's going away from me. So we've assigned priority 1, 2, 3. I'm moving my cursor in a counterclockwise direction. I'm going counterclockwise right now. Counterclockwise would normally be S, but I switched two groups. So I need to remember that I need to swap back to the real configuration, which is R. So this molecule would have a configuration of R, and I would encourage you to build the model and prove that to yourself so you can use two strategies to figure this out. Finally, there's one more thing we need to think about. What if we're given a molecule like this? Study this molecule carefully. Where's our chiral carbon? There it is. Let's look at the 4 groups that are directly bonded to our chiral carbon. A bromine, an oxygen, a carbon, and a carbon. Well, actually here, there's no hydrogen. It's not that we have to have a hydrogen every time. We just can still assign priority. We'll do it in the same way that we've always done it, where we say, okay, bromine, the atomic number of bromine is 35. The atomic number of oxygen is 8. The atomic number of carbon is 6. The atomic number of this carbon is 6. And just none of those being our hydrogen, right? But we need to figure out which carbon, this carbon over here or this carbon over here, which of those is going to be our lowest. So we'll use the same strategies that we've used in the other videos to recognize that we'll go one atom at a time. This carbon over here is bonded to 3 hydrogens. This carbon over here is bonded to another carbon, and so that receives the higher priority. So this is our first priority. This is our second priority. This group has our third priority. This group has our fourth priority. And then we see the problem is our fourth priority group is coming towards us. That's a problem. So we'll need to do either some rotations or swapping of two groups. If you do that, you will get a configuration for this molecule is R. So I would recommend you take two strategies and try and figure out the configuration for this molecule. You'll check yourself. The answer should be that it is R.